So that gives a bit of expectation. Okay, well, I'm going to speak in English, so I hope you will understand. Basically, my presentation about cutting 6 kilometers wood into 80 bridges. I've taught at the Institute of Architecture and Design in Aalborg, and I had 80 students, and we decided to sort of progress this. So what I'd like to present here is a methodology in architecture, is a process, and finally is some designs. What we're looking at and what we're focusing at with these sort of students is the tectonic tradition or the approach in tectonics, which basically one can bring down to the focus on materials, the properties, joints, assembly, the system that is derived from this, geometry, addition, and in the end, formation. So that are the essential focus points. What we want to get back to is also a form of architectural crafting. At the moment, the architects are sitting and sketching, but they have little connection to what they're actually building in the end, and therefore we like to bring architecture students closer to some sort of vernacular ideas, the touch with the material, and these sort of aspects. So they have to build it in hand. This also brings closer to the idea of a deeper understanding within architecture in the sense of bringing structure and architecture together. Tectonics can also be defined as the poetics of structure. And therefore, we also go in and look at the forces and force diagrams through the structures that we produce, which we are searching for. And therefore, we're trying to get further. So this implies an approach where we start with the beginning rather than the finished design, and then work our way inward. So the idea comes here from Bollman, who says that to reach the widest samples, the beginnings have to be simple and the smallest. And he's an engineer, but considered also as an architect. And I don't want to go into the larger theoretical framework of this, but the idea is normally that the architect sort of come up with a great concept, and from that he springs out and make a sketch. In this case, we want to both think, do, and the thinking is then provoked again from the doing. So it's an iterative process between, here you just see some images of some of the students where they're sitting working. Basically, the process runs in 3 phases. 5 days first, so they have to produce 15 models or small prototypes like these. The phase is called elements. Focus is, as said, only on material properties, joint, and geometry. So we're just really making deliberate practice going in, what is going on here, what is happening in the joint here. And these sort of aesthetical considerations in this phase is very important. But it's not allowed to go further in the process than just doing these small things. So basically, each student has what is called a research catalog. For each model, they document the model. They construct what is called a free body diagram, so the force flow within this small element. But how does the force travel through the joint? What is the aesthetics of it? What is the scale? What is the proportions? And so forth. The next phase is start to focus on the joint and the assembly of the system, additive process. How do we put several of these elements together as a unity? How will they work? How can we provoke their form? And how do we translate force through the structure? So we start again from the very beginning and go further. So what I didn't say before was that we have in the first phase they have to produce 15 models. In the second phase they produce 3 systems. And again analyze these of both of structural, aesthetical, tactile qualities, and in the end they have to describe these things, okay? So they have to go into the design more than just how does it look, how does it feel, and get further. So moving into the third phase, what we call formation. We talk here about holism, we talk about context, we talk about rhythm, space, formation as a general. So here we see some of the designs. The models were made in 1:20 because we obviously cannot in architecture build in 1:1, unfortunately. And this last iteration, this last phase, also then is documented with the image, the description, and then the overall concept and for architectural description of the project. And going through this method then implies that we could actually, in a rather complex structure, we're going to see a couple of images just in a minute, we can go into a single point in this model and understand it very in depth. So this is also an academic context, which means that there was a block made. It's about knowledge sharing, it's about knowledge growth and understanding of each other's projects. So there's a block made, all the information, each student had their own web page. They uploaded everyday material, so you can go into this website, it's still running. It's completely overloaded, and we got more than 11,000 hits on it. 5,000 of them were the students, so they were starting to discuss and interact in a very on a daily basis. What are you doing? How can I learn from you? How did you develop that joint? How did you go further? And the whole thing sort of exploded to then where I had to start to pay WordPress for more space. So I'm just going to take a couple of the images here of the bridges that was developed in the end. And what is interesting about this is that this, for instance, this small joint here, just setting it in 0.5 millimeter means that this sort of curvature and this unfolding geometry of the bridge is allowed. Plus, it allows the compression forces to be handled. So there's loads of different designs. Some of them are more spatial, dark here on the screen. But basically, there's a relation between the geometry, the proportions, and the movement. These are more sort of plan images of things to very complex bridge structures in the end, where we can, as said, we can take out each element and understand how it's working and appreciate its tactility. Here's another one where it sort of gives the idea of moving across 20 meters, and you have the flow of the model, and then we start to give an understanding. These models can be, they're static as they are at the moment, but we can understand them as formations and be able to potentially be transformed at another point. So here we see the 80 bridges exhibited for the review in Aalborg at the Platform 4, which is quite a big workshop laboratory space we have. So the 80 bridges with all their hundreds of small process models underneath posters, it was quite a nice scenario. So in the end, in 20 days, we had 6,000 meters of wood, 6,000 meters of black waxed thread that we used to connect the things with. More than 50,000 handmade cuts were made. More than 25,000 handmade joints. More than 25,000 handmade nuts. And these resulted then in 80 bridges and then in 20 days. So this was very intensive for the students. They were like, shit, they couldn't handle it. But then they came through. So therefore also had to spend my last slide on thanking them. They're not here today. They just handled in their second project of the semester today. So I hope they're either sleeping now or drinking glögg or beers. So thank you for allowing me to speak here, and I hope you enjoyed the slides.